Hi, this is Chris. This is a tutorial on basic sequencing and clocks in the Sema default language and the underlying Sema audio engine. We have three core functions for sequencing in Sema which we're going to look at in this tutorial. They all represent kind of building blocks which can be used for basic sequencing but also might be used as part of something more complex. In the next tutorial on the ratio sequencer, we'll see how these get used to build into more complex sequences. So first of all, we have a function called CLT. CLT is short for clock trigger, and what it does is it produces impulses synchronized with the underlying clock in the audio engine. We'll have a look at how to configure this clock slightly later in this tutorial. If you don't configure it, it runs at a default rate of 140 BPM and it has 4 beats per bar. Our function CLT produces triggers. In other tutorials we've looked at different ways of producing triggers, for example with a square wave or any audio signal that has positive zero crossings in it can be used as a trigger. CLT is useful as a triggering mechanism because it's synchronized to the main clock in the audio engine. So that means if you're using CLT in lots of different places to trigger different sequences, they will all be synchronized together, and also when you change the BPM of the clock, everything will stay in synchrony. So CLT is a very useful function if you want to kind of make larger scale sequences, clock sequences. Let's have a look at what this does. We've seen already in a different tutorial that you can trigger a sample by sending it a trigger. So here we are. This is a clocked impulse being sent to a 909 sample to trigger it. This number here is the number of impulses per bar. So in the normal impulse generator it's the number of impulses per second, here it's per bar. So here we're getting an impulse once at the start of every bar at 140 BPM. And if I change this, we'll get faster impulses. We can also go below zero, so this would be one trigger every 2 bars, for example. We can hear this a little bit better if we compare it to another sound. So let's try that. I'm going to put this channel into a variable called sound1, and then I'm going to make another sound. For simplicity, let's try a kick drum, and I'm going to call this sound2, and then I'm going to mix them together using a mix function. So let's see what that sounds like. So at the moment we have this snare and this kick drum playing at the same time once per bar. So now we can see the effects of this trigger a bit more easily. If I change this to 2, then we'll hear 2 snares for each bass drum. Or I could change this. The basics of how this function works. And as you can see, as I kept on evaluating this code, everything stayed in synchronization. We didn't kind of lose timing at any point, and that's because everything's synchronized to the underlying clock. This underlying clock then, how do we control that? We can use a function called CLK. This function takes 2 parameters. The first parameter is the beats per minute, and that lets the audio engine work out how long one beat will last. And the second parameter is the number of beats in a bar. Now this parameter is important because it determines when a new block of code will get evaluated. So in our live coding engine, what we're doing is we're running a block of code, and then we're doing some editing, and then we evaluate. We take this new block of code and swap it around in the background for the old block of code. And when that happens is dependent on when a new bar happens in the Sema audio engine. So if I say that if I run this and we're saying we're going at 140 BPM and a bar is 4 beats long, that means if I evaluate some new code, it will get replaced on every 4 beats. Or if I want code to get replaced more quickly, I could say get it to get replaced every 2 beats by making a bar 2 beats long. Let's have a quick look at this function. So you'll be able to hear if I increase the BPM, everything will speed up and stay in synchrony. And if I slow it down, the obvious will happen. The final sequencing function we can look at is called CLP, which is short for clock phase. And what this does is it outputs a phaser whose cycle length is you can control synchronized to the main clock in the audio engine. So if I run this command, 1CLP, it will output a phaser that has a cycle length of 1 bar. And it will become really evident how this is useful if you look at the ratio sequencer in the next tutorial. For now, let's try and sonify this so we can hear exactly what the function's doing. So let's put this in a variable, and we won't really be able to hear a phaser that's rising from 0 to 1 once per bar. It's too much of a low frequency, and so let's map it into, let's say, the frequency of a saw wave. So we can use the mapping tools that we've seen in the other mapping tutorial. What this is doing then is taking the phaser, which we know is unipolar, because it goes from 0 up to 1, and then mapping this into a frequency range of 20 up to 500, and putting it in this variable here. And then what we'll do is we'll listen to that. So we'll send that frequency to a saw oscillator, and then we can just put the listening operator here and see what it sounds like. If I increase the speed, just like CLT, this will increase the speed of the phaser. So this is the number of cycles per bar. If I put this at 4, we'll get 4 cycles per bar. And this will stay in synchronization with the clock, so if I change the BPM, the frequency of this phaser will change as well. And we can see that if we bring in these other two sounds here as well, then we'll be able to hear that the clock phaser and the clock trigger are all synchronized together. So these are the building blocks that we can use for sequencing in Sema. There's one final thing that we can look at, which is the phase and that's a second parameter here, a phase offset. If we set these to once per bar, and we can just delete this for now actually, then our second parameter is a phase offset. So if we have a trigger happening once per bar, if we give it a phase offset of 0, it'll always happen at the start of the bar. If we give it a phase offset of half, then it will be delayed until halfway through the bar, or 0.25, then it will happen a quarter of way through the bar. So this is a way of kind of offsetting different signals so they're not always kind of right on top of each other. Let's just hear what that sounds like. Okay, so those are the three building blocks of sequencing in Sema, and if you go to the ratio sequencer tutorial, we'll see how those get applied to make more complicated sequences.